In this video, we're going to be talking about imaginary numbers, and this is a completely different family of numbers. It says the imaginary unit, and that would be I, is defined as I is equal to the square root of -1, and that's the most basic unit in this family. This is useful when working with square roots that have of negative numbers, which we ran up to, and before we've said, well, we can't do this. We can't do it to obtain a real number. However, they are imaginary numbers. A pure imaginary number is written in the form bi, where b is the real number and I is the imaginary part. So you'll have pretty much a coefficient that is a real number like 2i, 3i, 4i, to where b will again be a real number. I is the imaginary part of that term. So here's how we actually simplify negative square roots so that we can obtain these numbers. And it works the exact same way as what we did with breaking apart radicals. The square root of -144 we simply write as the square root of +144 times the square root of -1. And once we break that into the a positive square root, which we know that we can find, square root of 144 is 12. Anytime you see the square root of -1, that is your most basic imaginary element, and that's going to be 12i. And that's it. That's all you have to do. The square root of -80, I'm going to split into the square root of 80 times the square root of -1. And then the square root of 80, of course, we can break down like we did in the previous video. That'd be square root of 16 times the square root of 5 times the square root of -1. And here's how I want you to get used to writing this. If it's a real number like 4, write it first. The I part comes next, and then if there's something left under the radical, we write it last. So that would be 4i root 5. And then the last one here, let's first split that into root 36 over 121 times the square root of -1. When you're taking a square root, you can separate this and take the square root of the top, square root of the bottom. That would be 6/11. Square root of -1 is I. Okay, now let's discuss the powers of I. I to the first, we already know. It is the square root of -1. And that is, and I'm going to come out here and just put plain I, and I'll show you why in just a second. I to the second power. Okay, if you were to take that I to the first power, which was the square root of -1, and now raise it to the second power. Reminder, anytime you square a square root, it removes the radical. So that would be the square root of -1 squared would be plain old -1. If you were to raise I to the third power, what I'm going to do is I'm going to use my rules of exponents. So I'm going to say that would be the same thing as I to the second times I to the first, which we just did. I to the second power was -1. I to the first power was I. If you were to multiply -1 times I, that would give you a -I. I to the fourth power, we could split it apart with rules of exponents. That'd be I to the second times I to the second. We just found out that I to the second power was -1, so this would be -1 times -1, which would be a +1. Okay, now let's go over here and see what happens when we do I to the fifth power. With all these powers, I can now say, well, that's I to the fourth times I to the first. And with every one of these, I to the fourth power was equal to 1 down here. So this is 1 times I to the first, which would be I. I to the sixth would be I to the fourth times I to the second. Like I said, we can split all these now into the I to the fourth ones. I to the fourth was, let's see, down here was 1 again. I to the second was -1. So you have 1 times -1, which is also -1. And hopefully you're seeing the pattern. I to the seventh is I to the fourth times I to the third, which is 1 times -I, which would be -I. And then finally, I to the eighth would be I to the fourth times I to the fourth, which is 1 times 1, which is 1. So you see the pattern. I to the first, second, third, fourth, fifth, sixth, seventh, eighth. If I were to ask you I to the ninth, I to the 10th, 11th, and 12th, the same thing happens. You get the exact same pattern. I, -1, -I, and +1. And that pattern will always repeat. I to the first, I to the second, and we need to memorize this pattern, I to the third, and I to the fourth. The key is I to this one right here, I to the fourth. This will be I to the fourth, eighth, 12th, any multiple of 4. you could really put I to the 4x. 4a, 12, 16 will always fall right here. So how do we evaluate now something like I to the 11th? If we remember our pattern, I, -1, -I, and +1, we know that this would be any multiple of 4. So all you have to do to find I to the 11th, find a multiple of 4 close to 11, and that would be 12. So if this is I to the 12th pattern, since to I to the 12th, since it follows that pattern, go back one, this would be I to the 11th. So I to the 11th would be -I. -3 times I to the 21st. Well, first off, let's find I to the 21st. Again, that same pattern. I'm just going to come over here and work it. If this is our pattern, let me zoom in. Right here would fall I to the 20th. So if you have, again, 18, 19, 20, to find I to the 21st, you start over. I to the 21st power would be just plain I. So here you have -3 times plain I. So there's really no such thing. Never leave your answer as I to the 5th, I to the 6th, I to the 7th. Always evaluate those. Okay, number 6, and for some reason, this is supposed to be a multiplication dot. For some reason, it got left off. So let me do that. So we're doing 6i to the 13th times 8i to the 3rd. And rules of exponents, we know 6 times 18 is 108. I to the 13th and I to the 3rd will be I to the 16th. Same rules of exponents apply. So our pattern, I, -1, -I, +1. All the multiples of 4, so this would be I to the 16th. Because 16 is a multiple of 4, so we're simply doing 108 times 1, which we know is 108. Okay, number 7. We're doing a power raised to a power. So we're going to raise 2 to the 5th power, and we're going to raise I to the 9th to the 5th power, which is I to the 45th power. First off, 2 to the 5th, that's old stuff. That's going to be 32. Then I to the 45th power, let's scroll up and just look at our powers here. A multiple of 4 close to 45 would be I to the 44th. So I to the 45th would start over here and would be just plain I. On number 8, we also left off the multiplication dot for some reason. So these two things are simply being multiplied together. In the first set of parentheses, -I squared to the 5th. We've got to raise both -1 to the 5th and I squared to the 5th. Because again, anytime you see a negative, it's like a -1. -1 to the 5th will still be a negative. I squared to the 5th will be I to the 10th. Times, we're raising everything in the second parentheses to -3rd power. So you have -3 to the 3rd, and I to the 10th to the 3rd will be I to the 30th. So we have a -1 here. And this turns out to be, let's go ahead and evaluate. -3 to the 3rd would be a -27. So we can actually combine our -1 and -27 gives us a +27. I to the 10th and I to the 30th is I to the 40th. All the multiples of 4 in our list falls, let's see, I, -1, -I, +1. This is all the multiples of 4, so that'd be I to the 40th would fall there. So this is simply 27 times 1, which is 27. Again, the multiplication symbol is left off. Now here's some advice. Always clean this up before you raise it to any kind of powers. Always clean it up first. So what I'm going to do is I'm going to break the square root of -9 into √9 times root -1. So that is 3i. So that'd be 3i to the 3rd power times, we got to raise both of these to the 6th power. We'll do it in the next step because I've got 2 over here as well. 3 to the 3rd times I to the 3rd times 2 to the 6th times I to the 6th. So that'd be 3 to the 3rd is 27 times 64. And I'll go ahead and multiply those two. You get 17, 28. Again, I did 3 times 3 times 3 is 27. 2 to the 6 was 64. Multiply together. Then you have I to the, just count your I's, you have 9. Pattern, this would be I to the 8th. So I to the 9th, you would just start over. It would be a regular I. So this would be 1,728 I. Okay, so now let's talk about the family that I discussed earlier, that I was a member of a different family, and that is the complex numbers. So if you go back and think, we had our real numbers, and our real numbers were broken into rational numbers and irrational numbers. And you might be wondering, well, where does these imaginary numbers come into play? Okay, the real number system is actually a part of a bigger number system called the complex numbers. And here's a picture of that system. Notice that you still have your real numbers over here. Oops. On the left, with your real numbers, your rational numbers, your irrational numbers, broken down just like they always have been. However, you have this other group of numbers over here called imaginary numbers that we've been dealing with. And inside these imaginary numbers, they have numbers like 3 plus 2i, 2i root 2, negative 4i. Well, all of these numbers make up the system of complex numbers. So that's the ones we're going to be dealing with in this lesson. So a complex number is written in the form a plus bi. Change back to my pen. A plus bi, to where a represents the real number part and bi represents the imaginary number part. So a complex number can have a real part and an imaginary part. And that's the reason that real and imaginaries are both in the complex number system. The real numbers that we've been dealing with are also complex, but they're pure real numbers. You also have pure imaginary numbers, like we discussed earlier. To add and subtract, we have all of our operations are also in this family. We can still add and subtract. We can still multiply. We can still divide by using the methods that we've always done. We're going to combine some like terms simply to add and subtract. To multiply, we distribute and then combine like terms. To divide, we multiply by I or the conjugate, just like rationalizing the denominator. So let's look at some operations and show you how easy that the operations of complex numbers are. Here, you're adding two complex numbers. Look, it has a real part, imaginary part. This one has a real and imaginary part. And to add or subtract two of these numbers, two of these complex numbers, these parentheses are really unnecessary because we're adding. We're just combining like terms. 6 and negative I is a negative 2. Negative 4i, positive 6i is a positive 2i. So you're done. There's your new complex number. To subtract, negative 3 plus 5i, the second set of parentheses, you distribute the negative 1. That'd be a negative 4 minus 6i. And then you, again, just combine like terms. Negative 7 minus 1i. And you're done. Number 12, here you're multiplying. This is pure imaginary times a complex number, so we distribute. 4i times negative 8 is a negative 32i. And then 4i times 5i is a positive 20i squared. Now, this is where your pattern comes into play. I to the first, I to the second, I to the third, I to the fourth. Anytime you have an I to the second or any other power, you're going to replace it with what it's equal to. So therefore, now you have negative 32i. This will be a positive 20 times negative 1, which is a negative 20. And most of the time, you're going to have your real part written first and your imaginary part written second in that a plus bi form. So negative 20 minus 32i. Next up, you have a real number times a complex, which is legal. That's 18 plus 12i. You just distribute. And then you have a pure imaginary times a complex number. And again, we're just distributing. Negative I times 5 would be negative 5i. And a negative times a negative would be a positive 7i squared. Anytime you have an I squared, again, according to this rule, I squared is negative 1. So we're going to take that out. And instead of times I squared, it is times negative 1. So a 7 times negative 1, to save me from having to rewrite this step, would be a negative 7. Now you're combining like terms. The real part goes first, so let's combine them first. 11, then 12i minus 5i would be a plus 7i. Okay, number 14. Again, we're just continuing with the operations. Here you have a complex number times a complex number. To do this, you distribute, you FOIL. 5 times 9 is, multiply this times both. 45 minus 40i. Multiply this by both. Positive 27i and a negative 24i squared. Again, anytime you have an I squared, we're going to replace this with a -1. So that would be 45 minus 40i plus 27i, and then -24 times a -1 would be a positive 24. To get it in a plus bi form, let's do our real part first. So let's do 45 and 24, which is 69. And then a -40 and a -27 will be a -13i. So notice when we multiply this complex number times this complex number, we got another complex number. Conjugates. Now something special happens with conjugates. Reminder to multiply conjugates, all we have to do is first times first and last times last. So 5 times 5 is 25. Positive 3i times a -3i will be a -9i squared. The middle terms would cancel anyway, so you don't have to worry about them. So this will be 25. Again, -9 times -1 will be a positive 9. Anytime you have I squared, replace it with -1. 25 plus 9 is 34. You actually get a real number. When you multiply conjugates, they're called complex conjugates because both of these are complex numbers. When you multiply complex conjugates, you always end up with real numbers. Number 16, to square, make sure again you don't square each piece, but you actually do 3 minus 11i times itself, because you do have to FOIL here. 3 times both gives you 9 minus 33i. -11i times both gives you -33i plus 121i squared. And you'll get into a habit of, since this is I squared anyway, of, okay, 121 times -1 is just going to be a -121. It just changes that sign. Real part first, 9 minus 121 is a -112. Then -33 and -33 is minus 66i. Okay, number 17. 17, you got a couple of operations here. First one, we have to distribute, so multiply 7 times both. That'll be 42 minus 7i. Multiply -2i times both. That'll be a -12i plus 2i squared. Distribute your 3. That'll be a 27 minus 15i. So now what I would do, since you have I squared is -1, you can either mark through this and write it over the top, or I'm just going to erase it. A positive 2 times a -1 right here would be a -2. Now let's combine our like terms. 42 minus 2 plus 27 would be 67. Combine your i's. -7, -12 would be -19, and -15 would be -34i. Okay, number 18. Anytime you're dividing by a complex number, by an imaginary number. Okay, reminder that this is a square root on bottom. And the same way that we got rid of square roots before, we're going to do the same. If you had the square root like 3 over √2, to get that root off bottom, we multiply top and bottom by √2. We do the same thing here. Since you have the square root of -1 on bottom, we're going to multiply top and bottom by the square root of -1. And that's going to get rid of it. So now on top you have 6i. On bottom you have 7i squared. And a reminder that I squared is -1. So that's going to be 7 times -1 on bottom, which is -7. And that's it. That negative can be written out front since it's a negative fraction. To get this I off bottom, again, just multiply top and bottom by the square root of -1. Top turns into 26i plus 4i squared. The bottom turns into 8i squared. So everywhere you have an I squared, let's put a -1. So the top is now 26i minus 4, and the bottom is -8. Okay, now let's actually reduce this, because all three of these values are divisible by 2. So we can write that as 13i minus 2 over -4. And I want you to get into a habit, because I want you to get into a habit of leaving your answers in a plus bi form. And this is definitely not. But we can get it there by splitting that. The distributive property, we're going to take 13i and divide by -4, and we can take -2 and divide by -4 as well. And then that's going to get us in our right form. A positive divided by a negative is a negative, so I can write that as -13 fourths I. and then a negative 2 divided by negative 4 is a positive 1/2. So write the real part first, imaginary part second. That'd be 1/2 minus 13/4 I. Then you can see what's my real part, what's my imaginary part for when we start graphing these. Okay, the bottom, 2 minus 6i, anytime you have a binomial on bottom, same way with that we did when we were talking about radicals, we multiply by the conjugate. So we're going to multiply top and bottom by 2 plus 6i, and that should get rid of that I on bottom. So on top you have 2i plus 6i squared. On bottom, when you multiply conjugates, all you have to do is first times first and last times last. That'd be minus 36i squared. So on top, we now have 2i plus 6 times negative 1. And I'm going to write, just for the sake of having it first, 6 times negative 1 will be a negative 6, and then plus the 2i. On bottom, negative 36 times I squared, that's negative 36 times negative 1, which would be a positive 36. So on bottom, you have 4 plus 36, which is 40. And again, you can split that. We can go ahead and divide everything by 2 first, if you'd like to. Negative 3 plus 1i over 20, and then we'll split it. That'd be negative 3 over 20 plus 1 over 20i. And that 1 was in front of the I, so there you go. Number 21. Same thing, you have 1 minus 3i on bottom. Let's multiply by 1 plus 3i to get rid of that I on bottom. Again, and this is just like we are dividing complex numbers is what we're doing here. A complex number divided by a complex number, and we're going to get another complex number. On top, we do have to FOIL this. Negative 5 times both would be negative 5 minus 15i. Positive 5i times both would be a positive 5i plus 15i squared. On bottom conjugates, 1 times 1 is 1. Negative 3i, positive 3i is a negative 3i, or negative 9i squared. On top, combine like terms and put your real stuff first. This will be 15 times I squared will be a negative 15. Combined with negative 5 is a negative 20. Negative 15 and a positive I is a negative 10i. On bottom, you have negative 9 times negative 1 will be a plus 9. So 1 plus 9 will be 10. And this will be very easy to distribute. And I wouldn't reduce it yet because as you distribute it, it's going to reduce itself. Negative 20 over 10, but you can either way. Minus 10 over 10i. That'll be a negative 2 minus 1i. Okay, the next one. See what they want us to do here. It says on this one, operations with negative radicals. So on this one, we're just going to have to change them first to imaginary form. Now, caution. Let me show you something. The square root of negative 4 times the square root of negative 9. You cannot multiply. Let me put does not equal the square root of 36. A negative times a negative would be a positive. However, you do have to clean these up, turn it into 2i and 3i, then multiply it, and you would not get 6. You would actually get negative 6 when you multiply these out. So make sure that before you multiply these radicals, if you have negative radicals or the square root of negatives, make sure you change them to complex numbers first or imaginary numbers first, and then do your operations with them. So we're going to have the square root of negative 1 times the square root of 15 times the square root of negative 1 times the square root of 5. So that's going to be I root 15 times I root 5. I times I would be I squared times root 5, 15 times root 5 is root 75. And you can see this is 5 times 3 and 5 times 1. So you have a couple of 5s there. So you should be able to break this apart. So that's going to be negative 1 times the square root of 25 times the square root of 3. Again, anytime you have I squared, that's negative 1. So this would be negative 1 times root 25 would be negative 1 times 5, which is negative 5 root 3. And the next one, number 23. Same thing, make sure you split the square root of negative 10 into the square root of negative 1 times the square root of 10. And the same thing with root negative 2 is root negative 1 times root 2. And put it better symbol there. So this would be I root 10, and this is I root 2. So here we now have 2I root 10 minus, or times, excuse me. And I don't like that they did not put parentheses around that, times negative 3I root 2's. Multiply what you can. 2 times negative 3 is a negative 6. I times I is I squared. Root 2 times root 10 is root 20. So you have a negative 6 times negative 1, which is a positive 6, times the square root of 20. Let's come over here and split that into root 4 times root 5. That would be 2 root 5, so we'll have one more step. 6 times 2 is 12 root 5. Number 24. We're going to split the square root of negative 2, and I'm just going to do it without writing it down. That would be I root 2, because we did the square root of negative 1 times the square root of 2, times 5. The square root of negative 6 will be I root 6, because that would be the square root of negative 1 times the square root of 6, plus root 18. Distributive property, I root 2 times 5 I root 6. We've got to multiply it by both. This is a 1. 1 times 5 is 5. I times I is I squared. Root 2 times root 6 is root 12. Plus 1 I root 2 times root 8 is root 36. Root 12 we can split into root 4 times root 3. So that'd be 2 root 3. So here we have 5 times negative 1. That's negative 5 times 2 root 3. Plus I root 36 would be the root square root of 36 is 6. Write the 6 first, 6I. So now we can do the negative 5 times 2 would be negative 10 root 3 plus 6I. And that is in A plus BI form, because negative 2 root 3 is real. That would be your A part. Negative 4 times the square root of negative 6. That'd be negative 4 times, split this into the square root of negative 1 times the square root of 6. And then in parentheses, you have 7 minus 3 root 12. 3 root 12, let's go ahead and clean that up. That's root 4 times root 3 is root 12, so that'd be 2 root 3. So this would be 3 times 2 root 3, which would be 6 root 3. And you didn't have to do that. It would actually might have came out clean the other way as well. It doesn't matter. Negative 4 times 7 is negative 28I root 6. And then times the second one, negative 4I times negative 6 would be a positive. 4 times 6 is 24. You count your i's, you have 1. 6 times 3 is root 18. We've got to do something with root 18. Let's split that now into root 9 times root 2, which is 3 root 2. 3 root 2. So you have negative 28I root 6 plus 3 times 24 would be 72I root 2. And we can leave our answer like that. If you wanted to see what the actual coefficient was on I, you could factor I out. This is not necessary, but you could write this as negative 28 root 6 plus 72 root 2 and put that in parentheses and put the I afterwards. And I just factored I out, is all I did on that step. Number 26, we are foiling here, distributive property. So your square root of negative 3, we need to turn that into i's first. So we're going to split that into the square root of negative 1 times the square root of 3. And then on the second one, negative 8 plus the same thing, square root of negative 1 times the square root of 3 here. That's going to be 2I root 3. You always have to do that before you multiply. 3 times both, that'd be negative 24 and a positive 6I root 3. Now I root 3 times both. Negative times a negative would be a positive 8I root 3. Nothing combined there. A negative times a positive would be a negative. I times 2I would be 2I squared. The square root of 3 times the square root of 3 is 3. A square root times itself will always be just that number. So negative 24. These actually combine. So it'd be plus 14I root 3. We can clean this up some. Let's see. This is negative 2 times negative 1. I squared is negative 1. That'd be a positive 2 times 3 would be a positive 6. Negative 24 and 6 is a negative 18 plus 14I root 3. If possible, write your real stuff first again and the imaginary stuff second. And number 27. To square this, and it looks pretty ugly, but to square this, we're going to have to write it twice and multiply it times itself. Let's go ahead and take care of, as we're writing it down, the square root of negative 2. That's the square root of negative 1 times the square root of 2. So there's what we're going to multiply by itself, negative 4I root 2 plus 1. This times both. And this is not bad to multiply because you're multiplying numbers with numbers, i's with i's, radicals with radicals. So negative 4 times negative 4 is 16. I times I is I squared. And the square root of 2 times square root of 2 is 2. Negative 4I root 2 times 1 is obviously itself. Now multiply this times both. 1 times negative 4I root 2 is the same thing. And then positive 1 times positive 1 is a positive 1. 16I squared. Now that you have I squareds, that's going to be a negative 1. This is 16 times negative 1, which is negative 16 times 2, which is negative 32. These two combine, that's a negative. And the reason they combine is because the I root 2's. You have 4I root 2's, another 4I root 2's. That'd be a total of 8 I root 2's. Anytime you're combining like terms, your variables, treat these like variables, will not change. And then the plus 1. Negative 32 and a positive 1 would be a negative 31 minus 8I root 2.